Hello friends, in this video we are going to discuss about superposition of two collinear harmonic oscillations having different frequencies. Okay, so before we start, please do subscribe the channel, hit the thumbs up button, also share with your friends, inspire me to create new contents for you and help me to grow my channel. And if you want to follow me on Insta, this is my Insta ID Oza OZHA Lakhyajit LAKHYAJIT 123. This is my Insta ID. You can follow me on Insta if you want. Okay, so now let's start. So superposition of two collinear harmonic oscillations having different frequencies. So let us suppose displacement equations of two collinear harmonic oscillations are given by y1 is equal to a1, this is amplitude, sine omega t plus alpha. Okay, so and another is y2 is equal to a2 sine here we are talking about different frequencies, so let me take this as omega dash t plus, and here the phase constant is also different, let it be delta. Okay, so now here you see from these two equations what we can do. Now let us consider that the difference between omega dash and omega is suppose delta omega. Let me take that way, so omega dash is equal to omega plus delta omega plus omega, and so let me write here this. Therefore this equation gonna be a2 sine, instead of omega dash we're gonna write del omega t plus omega t, we write omega t plus delta. That's what we're gonna have. Now let me interchange the order of these two. Just wait, let me write the omega t first and then del omega t. Okay, so now you see, let me consider these things as alpha dash. Okay, so let me consider this y2 is equal to a2 sine omega t plus alpha dash. Okay, so which means alpha dash is equal to delta omega t del omega t plus delta. Let me consider that way, right? Therefore the resultant displacement is given by y is equal to y1 plus y2, right? So let's put the value of y1 and y2, then that's going to be y is equal to a1 sine omega t plus alpha a2 sine omega t plus alpha dash. That's what we have got. Let me write it clearly, a2 sine omega t plus alpha dash, right, plus alpha dash. So if we use trigonometric identity of sine a plus b, right, if we use that, what we're going to get, a sine a, that is here sine omega t, then cos b is cos alpha here, then plus a2 cos omega t, that is cos a sine b is sine alpha in this case. So in this case what we're going to have, plus a2 sine omega t cos alpha dash. Here you can see this is alpha dash, this is alpha dash, right? So plus a2 then cos omega t sine alpha dash. That's what we're gonna have. Now let's take common. What are the things that we can take common? So here we're gonna take sine omega t common, then within bracket we're gonna have a1 cos alpha plus a2 cos alpha dash into sine omega t, that's what we have got, then plus, and here we can take cos omega t common, then a2 sine alpha plus a2 sine alpha dash into cos omega t, that's what we have taken common, right? Sorry, I think I have made a mistake here. This is supposed to be a1, right? This is a1, so here this is gonna be 1, right? So hope you have understood this. Now let me consider this is as cos phi, a cos phi, where a is the resultant amplitude, and let it be a sine phi. Okay, so now let me copy this last step and let me go to a new slide. Okay, let me take a new slide. So this is y, the resultant displacement, right? Let me copy this. Okay, so here we go. This is the last step we have got. Okay, let this is just wait, give me a second. Okay, so this is equal to a, capital A, cos phi, and this is equal to, just wait, this one is equal to a sine phi. Okay, so now this is equation number 1 and this is equation number 2. Dividing equation number 2 by 1, equation number 2 divided by equation number 1, then what you're gonna have, so dividing sine phi by cos phi, you're gonna get tan phi, right? Tan phi, a gonna be cancelled if you divide. Okay, then you're gonna have tan phi, then in the denominator, sorry, in the numerator, left hand side of the equation number 2 is this, and right hand side of the, sorry, left hand side of the equation number 1 is this. This is what we're gonna have, right? So now from here, what we can write, a1 sine alpha, that's fine. Okay, then a2, we have already got that alpha dash that we have considered is equal to del omega t plus plus delta, right? So here you see this one where I have written this one, right? So that's what we have got. So if we put here again that value, then we're gonna have sine del omega t plus delta and divided by a2 cos alpha plus a2 cos, again here this will be replaced by this value, then what we're gonna have, del omega t plus alpha. Here this is nothing but the phase difference, so phi, that's gonna be tan inverse of this, right? Just wait. So here we have got. Now let me tell you one thing, that here it is function of t, so here phase changes with time. So now what will be the resultant amplitude? How to obtain the resultant amplitude? If you square and add the equation number 1 and 2, squaring and adding equation number 2, then what you're gonna have, you're gonna have a square. So if you square this one and this one, then add, then you're gonna have a square common, then within bracket you're gonna have sine square plus cos square, that's gonna be equal to 1, sine square 5 plus cos square 1, so that's gonna be a square. On the right hand side, just what we're gonna have is square of this, so a1 cos alpha plus a2 cos alpha dash square plus, then what we're gonna have, a1 sine alpha a2 sine alpha dash whole square, right? That's what we're gonna have. Okay, so if we simplify all these things, then using a plus b whole square and all these things, then what we're gonna have, a square cos square alpha plus a2 square cos square alpha dash, then plus twice a1 a2 cos alpha, then cos alpha dash. So similarly, plus a1 square sine square alpha plus a2 square sine alpha dash, sorry, sine square alpha dash, then plus 2a1 a2 sine alpha, then sine alpha dash. That's what we're gonna have. So if you take a1 square common from these two terms, then again you're gonna have a1 square within bracket sine square plus alpha cos square plus alpha, which is gonna be 1. And then similarly from here also we're gonna have a square a2 square within bracket cos square alpha dash sine square alpha dash. That's gonna be again 1 into a2 square is a2 square, and from here 1 into a1 square is a1 square. That's what we're gonna have. So in the next slide, so let me copy this, just this is a square, so let me copy this and let me go back to the let me take a new slide here. So here is the last result we have got. So we're gonna have a1 square plus a2 square after taking common and applying a square sine square plus cos square alpha, that's gonna be equal to 1, right? So if you take a1 square common from these two terms, then within bracket you're gonna get this one plus this one, which is equal to 1. So that's why we have here a1 square. Similarly, we have got a2 square from these two terms, right? And you can take this common, then 2a1 a2. So within bracket we're gonna have cos alpha dash, then plus sine alpha dash, which is nothing but cos alpha minus alpha dash, right? a1 square plus a2 square plus a1 a2, here it can be written as cos alpha minus alpha dash, and that's what we have got. So a will be equal to square root of a1 square plus a2 square plus 2a1 a2 cos alpha, and instead of minus alpha dash, what you can write, omega t plus delta, which is gonna be again minus delta, right? That's what we can write. On taking minus sign common, you can write this one as well, a1 square plus a2 square plus 2a1 a2, then cos of minus theta is cos theta. On taking minus, here we can write that and here you see omega, the del t, it can be written, omega, del omega is, we have considered that omega dash minus omega, right? So let me use that. So here alpha minus, if you put this one here, then it's gonna be omega dash minus plus omega, and t should be there, right? So we can take, okay, plus omega t. So we have not taken the minus common right here, so minus that's what we have got. So it can be written this way also, a1 square plus a2 square plus 2a1 a2 and cos, right, okay, just to wait, if you take the minus, sorry, not minus, if you just wait, if you write this, just give me a second. Okay, you can take the t common, so that you can write this, and then minus del minus alpha, right? This is what we're gonna have. So this is the resultant amplitude. So hope you have understood this. So thank you for watching. See you in the next video.